In our last video, we broke down the basics of how the attention mechanism works. Today, we're diving into the modern attention techniques that power LLMs. Using the concepts behind Minimind as an example, we'll be talking about the KV cache, grouped query attention, GQA, and flash attention. First, it's crucial to understand the KV cache, because GQA and flash attention are designed to work with it. During the process of generating new text, an LLM works in an autoregressive way, predicting one word or token at a time. To do this, it needs to reevaluate the attention mechanism over all the previous tokens in the sequence. Without the KV cache, the model would have to recalculate the key and value vectors for every single past token with each new prediction, which is incredibly inefficient. To solve this, the model stores these key and value vectors in a memory bank called the KV cache. This allows the model to only compute the key and value vectors for the new token, and then simply retrieve the cached vectors for all the previous tokens. This dramatically speeds up the generation process. Let's look at a concrete example to make this clearer. Imagine our model has already generated 511 tokens in a conversation. Now, it needs to predict the 512th token. Without the KV cache, the model would have to recompute the key and value vectors for all 511 of the previous tokens, and then compute them for the new 512th token, and do that for every single step. That's an enormous amount of redundant calculation. But with the KV cache, it's much simpler. We've already stored the key and value vectors for the first 511 tokens. When we get to our new 512th token, the model only needs to calculate the new key and value vectors for that single token. It then simply adds them to the cache. So, for the next step, we have 512 tokens worth of key and value vectors ready to go. This simple optimization is the key idea behind the KV cache. It prevents the model from doing the same work over and over again. It reuses the past computations, leading to a much faster and more efficient text generation process. In conclusion, the KV cache is a fundamental optimization that drastically reduces repeated computations and significantly speeds up the autoregressive decoding process in modern large language models. However, the cache itself can become a massive bottleneck. With long conversations or large models, it can consume a significant amount of GPU memory, limiting how much text the model can handle or how many users it can serve at once. This is where advanced techniques like GQA and flash attention come in. They're designed to make this memory usage even more efficient, allowing for faster and longer context generation. Thanks for watching. I hope this video was a helpful step in your AI journey. If you found it valuable, feel free to like and subscribe so that you can be notified of any upcoming videos. Thanks for joining me today.